Good afternoon, pre-calculus students. So welcome back to Mr. Chen's channel. So this one, just want to talk about parametric equation today. So here's what we got for sections 9.5. So this one is one of the particular sections for the parametric equation. So parametric equation is defined by the curve x equals f of t and y equals g of t, and where t is the parameter. So sometimes t is the parameter. It could be considered a either the time or the angle or any kind of parameter. So the first thing that you want to do, you want to eliminate the parameter and then sketch the graph. State the restriction on x, y, and t. Okay, so let's take a look at the first one. Okay, let me just snip this whole thing here. Okay, so the first one and the second one as well. Okay, so first thing that you want to do, you want to condense the parametric equation. So x, that means it's considered the horizontal component, and then y would be the vertical component. So the way that you want to condense it, you can always just name them. So x equals t, the first equation. Second equation, y equals t squared minus 1. So using substitution, so what we got here, y equals x squared minus 1. And we do know that it's a parabola. Okay, so after you condense it, so sketch the graph. It's a parabola. So started with the center at 0, -1. And then try to find the x-intercept. You'll get -1, 0, 1, 0. And then at 2, you'll get 2, 3. And then -2, 3. So connect them. So it's a parabola. And the specialty about the parametric equation is that we can always verify the pathway of the parametric equation. So let's say that you set up the table, so t equals 0, and then you want to find out x and y. Then that means x would be 0, then y, it's -1, so which is the initial position. And then what about t goes to -1? So -1, that means x could be -1, and then y, then that would be considered 0, so -1, 0. So that means going this way. So -2, so -2 for x, and then -2 quantity squared 4 minus 1, then that would be 3. So -2, 3, and that would be over here. So this one basically shows the pathway of the parametric equation. And then what about if t goes to positive? The positive value, 1. So we got x equals 1. 1 squared minus 1, then that would be 0. 1, 0. And then plug in 2. So we got 2. So 2 squared minus 1, then that would be 3. 2, 3 up here. So that means it's going toward the other direction. So put in the arrow like that. And what about for b? Quite similar, but before you do that, you want to square both sides to get rid of the radical. So that means x squared equals t. So put into that the second equation. So y equals 1 minus t, so 1 minus x squared. So another quadratic parabola. Rewrite it, so y equals -x squared plus 1. So the vertex 0, 1 with the x-intercept -1, 0, 1, 0. And then a -2, so it's 3, -3, positive 2, 3. Again, so this one it shows that the parabola. Okay, so we don't want to make it out of bounds, so just stop there. And then this one you want to find out the restriction. For the previous one, we need to find a restriction as well. So according to that, the linear quadratic function, so t has no restriction. So for t this one, so t could be -infinity to infinity. And then same thing happened for x, -infinity to infinity. But for y, as you can see the graph here, so this one is bounded from 1, and then it's all the way to infinity. So put in with the interval notation, so -infinity to infinity. And then this one open bracket at 1, and then all the way to infinity. And this one here, it's just put in some kind of analysis, so t must be greater than or equal to 0, well, otherwise, the result would be imaginary. So that means t must be considered 0 or greater than 0. And then for the other one, so for x, so this one's similar, so 0 to infinity. And then for y, then y would be considered negative infinity all the way to 1. So that means the graph here, just set up the table. So this one is only going this way. So there's nothing here on the left hand side, because that would be imaginary number. So it's only a half parabola, half of the parabola. Okay, so now let's see what else that we have for this template. Okay, let's do one with the trig function. So for d, okay, so we can do both d and e. Okay, so for d, first thing that you want to do, so try to find a way to get that t right there. So basically just square both sides for the equation. So what we found here is x squared equals 4 sine square of t. And then y squared equals 4 cosine square of t. And then one thing that we noticed, combine the equation, we do have x squared plus y squared. And then the right hand side, combine them. So 4 sine square of t plus 4 cosine square of t. So take out the greatest common factor, so we do have sine square of t plus cosine square of t. According to the identity, which is 1, so 4, so x squared plus y squared equals 4. And this one, the good thing about that, it tells you the rotation. So from 0 to pi, here's pi over 2. So the center, equation of a circle, so 0, 0. So radius, which is 2. It's a conic section. So 2 units to the right, 2 units to the left, 2 units up. So it's going one direction this way. From 0 to pi. So here shows the pathway. And then the restricted value for x, so this one would be negative 2 to 2. And then for y, the restricted value, then this one would be considered 0 to 2. And then what about this one? Similar, square both sides. So x squared equals cotangent square of theta. And then y squared equals cosecant square of theta. So one thing that we notice, cosecant square of theta, which is y squared minus x squared minus cotangent square of theta. So that's just the Pythagorean identity. So this one turns out to be a hyperbola. So center, h comma k, so the formula is y minus k quantity squared over a squared minus x minus h quantity squared over b squared. So that equals 1. So the center is h comma k, which is 0, 0. Once again, 0, 0. And the vertex, so this one tells you that the value of a, which is 1. So 1 unit up, 1 unit down. And also, hyperbola that involved with the slant asymptote. So for the slant asymptote, then that will be considered y minus k equals plus minus b over a, x minus h. So it's y minus 0 equals plus minus, well, b and a, which is 1 and 1, 1 over 1, x minus 0. So basically just y equals plus minus 1x. So 1 unit up, 1 unit to the right, or to the 1 unit down, 1 unit to the left. Asymptotes. Here's another one. And also the opposite directions. And then this one basically just connect them. It's a parabola for the first part. And here's another one. So the whole thing here is called the hyperbola. And then find out the restrictions. So this one, both of them, while they share with that sine of theta down the bottom, you just rewrite it. So x equals cosine of theta over sine theta. And then y equals 1 over sine theta. So denominator cannot be 0. So you set the denominator equals 0. So you find out the restricted value. So theta cannot be 0. Cannot be pi. It cannot be 2 pi. So which means is what? 0 plus minus pi k. So where k, it's all the natural number. Okay, so for the restricted value of theta. And then for x, as you can see that here, so basically x could be any real number. So x, the restricted value, negative infinity to infinity. And then for y, this one is being bounded. Okay, so got to be very careful for y, it's being cut off here. So for y, this one, it goes all the way from negative infinity to negative 1, union, and then 1 to positive infinity. Okay, so this one's theta, the element of theta. And this one is for x, and this one is for y. Okay, so now let's see what else that we have for this template. Okay, so the next one, determine the value of parameter t for which the following graph will trace itself once, twice. Determine the restriction. Again, square both sides and then try to combine them together. So once, that means you're going around one cycle, twice. So this one will be 2 cycle. And then determine the restrictions. So quite similar to what we did for the previous one. So number 3. Okay, number 3, the first one is quite similar to, so x, it's already done, solve for t in terms of x, put it into for y. Okay, so we'll do some of this. And again, the restricted value, you can just verify them by using the table, the t table, or the txy table. So this one, no need to sketch the graph, but how do we verify it? Okay, so for a, so this one, solve for t first. So it's 1 over x. And then y, we do have t plus 1. So instead of using t, we're using 1 over x plus 1. So we do know that's a rational function. So according to the rational function here, so t pretty much could be anything except 0. So the way to express that, negative infinity to 0, union 0 to infinity. And then what about for x? Similar, it's in the denominator. So negative infinity to 0, union 0 to infinity. And also for y, so y basically that shows the horizontal asymptote. Okay, so just like making a graph like this. Okay, so 1 unit up. So that means the horizontal asymptote cannot be 1. So it's going this way, going this way. We try to make the graph roughly. So y, then that'd be negative infinity to 1, union, and then 1 to infinity. So it's all about the analytic of the functions, you know, going back to the transformation. And then b, quite similar to what we did earlier. So x squared, so that equals 4 secant square of t. And then y squared equals 9 tangent square of t. For the things that you're thinking about to put this all together. Okay, so we do know that secant square minus tangent square, then that would be considered 1. But somehow this one we do have a different coefficient. So before you squared it, so here's what we can do. Okay, let me just clear up all the notation. So for b, let's start it over again. So divided by 2 first, isolate that secant of t. And then for y over 3, isolate that tangent of t. So square both sides, so we do have x squared over 4 equals secant square of t. Also this one, square both sides, so we do have y squared over 9. So that equals tangent square of t. So x squared over 4 minus y squared over 9. subtract secant square of t minus tangent square of t, that's 1. So that's just another hyperbola. It's another horizontal hyperbola. So this one, just find the value of a and b, sketch the graph, center, 0, 0, and then find out the restriction for t. The way to find the restriction for t, so set that, well, let's see. So we do know that's a secant, so it's 1 over cosine. So x is considered 2 over cosine of t. And then for y, similar, so 3 sine of t over cosine of t. So set that cosine of t equals 0, and find out all the 0 here for t. And try to get all the restricted value. And then x and y, similar to what we did for the previous problem. So identifying that the boundary, so it looks like x could be, well, if that's horizontal, so there should be a restriction for this one here. So it looks like this one is negative infinity to negative 2 union, and then 2 to infinity. And then for y, pretty much y could be any real number, because this one is a horizontal hyperbola. Okay, let's do the one for c. So this one, we do know that x equals e to the power of 2t. So basically this one is written as e to the power of t. E to the power of t. Well, let's see. Or this one can be written as e to the power of t, quantity squared, power to power. So y equals e to the power of t. So basically what we can do, so just say that x equals y, quantity squared, and then square root both sides. So this one looks like it's going to be a sideways parabola, because that's square root of y squared, so quadratic, so it could be positive, negative, plus minus square root of x. You know, some people thought that it's just like y equals square root of x. Well, let's find out which one is true. Let's put in the analysis. So it doesn't matter whether that t could be negative, positive, or 0. So eventually this whole thing, they always consider exponential growth. So they both consider exponential growth. They try to separate those two functions out. So that means they always guarantee that they're being positive. So since they're being positive, so that means this one is going to be positive. So instead of being the sideways parabola, so it's only going this way, this direction. So for t, so it could be negative infinity to infinity. And then for x, so x, as you can see that here, so it's always being bounded from 0 to infinity, but 0 is not included. And also for y, 0 to infinity. Okay. And now let's do one of those complicated ones. So for d, just like b right there, using that isolated variable. Isolate that cotangent of t, cosecant of t, and then square both sides. But let's do e, and let's see what else. Okay, so let's do e, f, and g, the way to convert them. Okay, clear all the notation. So for e, so this one, isolate that cosine of theta. So x minus 1 over 2 equals cosine of theta. Subtract 1 both sides, divided by 2. And then here, y plus 1, so that equals sine of theta. So again, combine the equations, so x minus 1. Well, before we combine them, square both sides first. So we do have x minus 1, quantity square, over 4. So that plus y plus 1, quantity square. So that equals cosine square of theta plus sine square of theta. And for those you might be wondering what this one is, it's just the equation of ellipse. It's a horizontal ellipse. You guys do recognize that back to what we did last year, Algebra 2. Okay, so it's a horizontal ellipse. Started with the center at 1, comma, negative 1. down here. And then for the vertex, so A, which is 2, so 2 units to the right, 2 units to the left. And then the vertical covertices, 1 unit up, 1 unit down. So it's a horizontal ellipse. Okay, so state that the restrictions, so this one is, okay, so for theta, so it looks like there's no restriction for this one, because basically that's just like a normal linear trig function. So theta, you just consider negative infinity to infinity. And then for t, not for t, for x, then that'll be bounded from -1 all the way to 3. You can put it in interval notation or the inequality notation. And then for y, so for y, then that'll be considered down here, -2 all the way to 0. Okay, like that. Okay, so now what about for f? So this one shows that x equals negative sine t. And then for y, that shows tangent of t. So tangent, which is considered sine over cosine. Okay, so the way to put this together, so this one, it's kind of a little bit tricky because you want to solve for sine of t in terms of x first. And then you try to put in all this together. Okay, so in order to eliminate that t, so there are certain things that you need to simplify. Okay, so in order to convert this one to tangent, so one thing that we notice, we can plug in that negative x for sine of t. Okay, so you try to do it that way, then that would be kind of considered like a substitution. Okay, so let's see what else that we can do here. Okay, so it's a little bit complicated with this one. So sine of t, we try to do the replacement. You try to do the replacement. So what we got here is showing that cosine of t, y equals sine of t. Okay, so that means x, so that equals negative cosine of t, y, replacement. But the t is still there, so that won't work. Okay, so that won't work. Okay, so think about it the other way around. Okay, so sine of t, cosine of t. So we try to get rid of that sine. So this one is one of the interesting ones to think about. You try to square both sides, so we do have x squared equals sine square of t. The negative doesn't matter. Y squared, so we do have tangent square of t. Okay? But once we combine them, we cannot use any kind of trig identity. Okay, let's see any other way that we can solve for this. Okay, so that's something you guys probably want to think about, but let's move on to the next one first. So for g, another difficult one, so x equals cosine of theta. And then y, we do have 4 sine theta, cosine theta. So think about the way to relate it with cotangent of theta with this one. So you might be wondering, cotangent is considered cosine over sine. It is. So what happened for this one here? So let's say if I try to rationalize it, multiply the top and the bottom by 1 over sine of theta. 1 over sine of theta. 1 over sine square of theta, actually. So what we got here, so sine of theta got cancelled, so we do have cosine over sine. And then the denominator, it just considered cosecant square. Because that 1 over sine square. So on top right here, so we do have 4 cotangent of theta. And then denominator, we do have 1 plus cotangent square of theta. So that equals y. And then with the replacement, so the replacement, what we got here, so we do have cotangent of theta equals x. So we direct substitution, so 4x over 1 plus x squared. So it's going to be a rational function. So that one is kind of interesting. Okay, so now what about for this one? Can we do something similar to what we just did there? Okay, let's see. So we try to convert that to sine. Okay, so in order to convert that to sine, so we do have, okay, let's put it this way. So y right here, so sine of t. So cosine of t, we can use that the Pythagorean identity. Rewrite cosine as sine, then that'd be 1 minus sine of t. And then using the replacement, okay, so this one it's written as y equals, well, we do know that sine of t, negative x equals sine of t. So negative x over the denominator, so square root of 1 plus x. Because negative sine t, which is x. So 1 plus x. So this one is a rational, it's a radical of a rational function. Again, find out the restricted value for x just by interpreting that the domain, the range. And then looks like t here, and it cannot be 0, cannot be pi. Well, it cannot be pi over 2, cannot be 3 pi over 2. And also it cannot be 5 pi over 2, so on and so forth. And then x here, it cannot be negative 1. And also it cannot be anything less than negative 1. Okay? So this one looks like x could be anything, y could be anything, but what about for theta? And also theta looks like could be anything except, well, this one is over sine, so it cannot be 0, cannot be pi, like that. So it's all about the interpretation of the trig functions and also the original rational function. So find the domain and the range for the restricted value. Okay, so going back to the template, let's see what else that we have right here. Okay, so this one just shows the graph, making a graph. So you want to explain that, whether it follow through the orientation or not. Again, anytime that you want to check the graph, you can always put into the calculator. But before you do that, make sure that you change the mode from functions to parametric. And then you type in the function with y equal, all that. So this one is just one of the example. Cotangent of t, 4 sine of t, cosine of t, the one that we just did. So press zoom and then 6. Here we go. So generate the model, the one that we came up with, which is 4x over 1 plus x squared. Okay, so compare to the original graph. So back to the function. Mode, convert it back to the function and put in that 4x over the quantity 1 plus x squared. Okay, so check this. Same thing. Okay, so now let's see what else. Okay, so things that we have for the rest of the study packet here. So this one again. So try to eliminate the parameter. So try to end up with one unique function and then put in that as a normal graph. So this one is just describing what's happening. So if t is getting bigger and bigger, so you want to describe what happened with the trend of that x and y. So if t is increasing, so that means x is actually what? Decreasing, because that x is going back to negative region. And then t is increasing, that means y is going back, it's actually increasing. So the way to describe it, so as t increases from t equals 0 to t equals pi over 8, so y increases and x decreases, like that. And then you want to describe what's happening from pi over 8 to pi over 4. So it looks like x is what? Consider decreases. And then the other one is for y, it's also decreasing as well. So t increasing, so that means y is actually, well, depending on from where to where, from negative 2 to 0, so y is decreasing. And then from 0 to 2, so y is increasing. And then for x, it's increasing all the way through from negative 2 to 2, because that the number is getting bigger and bigger. Okay, so it just describes the trend. Okay, so basically this one, that's it. So make sure that you know how to convert the equations, the parametric, back to the regular functions, and then just sketch the graph by using transformation. Okay, so thank you for watching the video today. So I'll see you guys next time.